Let's look at another example. If I said, use set builder notation. So remember, set builder is the one where we're still going to use our little braces. But on the inside, I'm going to use X. You can use whatever letter you want. Just put that letter first so we all know that that's what you're using to represent stuff. X such that. Well, let's see. In the problem, we have numbers greater than or equal to 4. Okay? So my X, whatever number it is I'm talking about, will always be greater than or equal to 4. And what are they going to come from? What kind of numbers are they? The integers? Are they just the counting real numbers, or the natural numbers? In this case, they're real numbers. Nice. So I'm going to say comma, where X is an element of the real numbers. Just for fun here, I want you to note that real numbers can also be represented with a bold R. That's the same thing. You won't see this in the book, I don't believe, yet. That's normally for higher math classes, higher level classes. So you're welcome to just write element of real numbers. That's fine. But if you see a bold R, that's what we're talking about. That's what you're reading. So up here was represented with our inequality, numbers greater than or equal to 4. And then we told which numbers we were including. With set builder notation, it is always assumed, so the default is that you're using real numbers. Element of the real numbers. Another correct answer to representing the example we're doing right now. This right here could also be written as X such that X is bigger than or equal to 4. You can stop there because it was the real numbers. And that's assumed. If you don't write it, real numbers, X element of the real numbers is assumed when not written. Does it make a difference that I'm being careful with where X comes from? Sure. It makes a huge difference. Because remember, in this example back here with X less than 10, we were only collecting the whole numbers. Remember, again, it was just 1, 2, 3, 4, not stuff in between. So what's the difference again between integers and real numbers? What am I getting to keep with the real numbers that I wouldn't have had with the integers? Well, actually a lot. Integers plus more, right? If I wanted to graph this solution, I could actually put it on a graph very easily. So here's a number line. Again, going forever this way and forever to the left. And note for me that if I were to refer to a number, say right here, that's not an integer. It's not a whole number, is it? In between 0 and 1, well, you could get lots of stuff, 1/2, 3/4, 0.75, 0.45, or 4500ths, however you want to say it. But the idea is that on this line, you could actually represent stuff in between the whole numbers, fractions and decimals. That's what real numbers include. Real numbers include everything. Real numbers include everything. Well, everything real. You haven't learned about imaginary yet, but basically everything being decimals, fractions, whole numbers, positive and negative numbers, all that is included in the real category. So we can represent it very easily on a graph without worrying about coloring places or putting dots in places that aren't legit. With the integers a second ago, we couldn't have done this. We would have had to put just dots on the actual number. But for these, this thing is saying 4, include your 4, I'll put a dot, a filled in circle, and go bigger than. bigger than 4 we know is to the right. So I'll shade to the right. A trick is if your X is on the left and the number's over here, you can just look at the way it's pointing. So it say go to 4, color this way, color to the right. Something to notice is that even though I'm using a filled in dot here because it was equal, it would have been an open dot if it had not been equal, right? I can also use a bracket and shade over. Both are okay with me. I do not care which one you use. I'll probably start to use a bracket just because that's what the author does, but notice that these mean the same thing. And then of course if you wanted to use an open circle, that's the same as using a parenthesis. And of course, notice the bracket's turned inward to point the way the arrow goes. So I would have flipped it if it had gone the other way. So that's just a note for you, that if you were coloring, you'd have an open circle or parentheses if it's not equal to, if the bar is not on that inequality, so that would have been for less than or for greater than. And in this example, since there was an equals on there, we put a dot or a bracket and we colored. Whichever one you use though, put it exactly on the number line. Don't put it above, put it exactly on the numbers. And of course we were able to graph it because it was the real numbers, so it was easy just to color since it did include those numbers in between the 4, 5, 6, and on and on. It included the fractions and the decimals. Let's practice graphing a few more, and then I'm going to describe something else to you. As far as combining sets, combining groups of data or elements. But first, practice graphing. So for example, if I said, graph for me x such that x is bigger than 1. If I don't say the type of number, the category, if I don't say x is an element of, remember it's from the reals. So I can just use a normal number line and just color at leisure, because everything will be included that I color. So let's see, I have 0, 1, 2, 3. So bigger than 1. Notice there's no equal sign under here. There's not that bar, so it's not going to include the 1. It will not include 1, so I'll put an open circle. And it's going this way, right? Bigger stuff. So I'll color this way for the bigger stuff. And of course, like I said a second ago, the same answer could have been seen this way. Once again, a number line. But this time, since I used an open circle, you could have selected a parenthesis. And I open the parenthesis up towards the direction of the coloring, like that. So these are the same. They both mean x always bigger than 1. Let's try one more, and then I'll add something to the twist here. So let's graph x such that x is less than or equal to -3. And I'll keep it in the reals, so I'll just close this off now. To graph this, 0, 1, 2, 3, -1, -2, -3, -4, it goes on and on, remember both directions. This time we have equal to, see the bar? So I go to the number, -3, and I'll plot a closed point since I'm including that. Stuff smaller, remember, is to the left, so I'm going to shade left because everything to the left is included. When I've got the X written on that side, on the left-hand side, I can also look at this as being an arrow. Hey, shade that way. Again, if I wanted to use different notation, if I wanted to use my parentheses versus my brackets, in this case, since it's a closed circle, it would be a bracket. So I could have said, okay, well, the closed dot is the same as, using those. And remember, we open them up in the direction of coloring. So when I went to my -3, I'm going to open it this way because that's the way I'm coloring. Again, use whichever one makes you the most comfortable. When you check in the back of the book, you'll see this. And